Okay. Good day to you if you are watching this on Nearpod. This is some practice for metric conversions. And we are going to look at a couple of different ways to look into how to convert using metric units. Okay, so when we think about metric units, we need to think about more than maybe meters. Sorry, this should be lowercase meters. Meters, liters, and grams. Those are what we call our base units. Okay? But when we think about metric conversions, we need to think about these base units, but we need to think about some other base units. Okay, so in the metric system, we have meters, liters, and grams, but we also have what's called a Newton, and that is a way to measure. That's a way to measure for force. So we've all heard of pounds, correct? So pounds is this lb, but that doesn't mean anything in metrics. That is not a base unit for metrics. Okay, so some other base units. We do have seconds. We can use seconds in metrics. We can also use the pascals. Okay, this is pressure. And we were not going to be doing too much of that in this class, but just know that. Also, we have watts, we have joules, and we also have what's called mixed units. Okay, so but these are just our base units. Okay, so just think about these for right now. Okay, so these are all of our base units. We also have mixed base units. So for Pascal seconds, so that's pascals times seconds. And then we also have meters per second. And then we have meters per second squared. Okay, and these mixed base units, these are using our base units. Okay, so you see how I've got a Pascal up here in my base units. I've got my meters up here, my seconds, and then this is just seconds squared. These are mixed base units. Okay, now when we think about either one of these, we're not going to be really using our mixed base units in this class, but just know that that's a thing. When we think about the base units, we need to think about where they go for our metric conversion chart. Okay, does everyone remember, hopefully remember, our metric conversion chart? Okay, that is this shorthand chart. Okay, and then there's Pico there at the end. Okay, so now my metric conversion chart, we need to think about where our base units go. And they go right here This is our base unit. Okay. And now let's think about why we have this O here. Okay. And the O, we could write like a big B here. But the reason why we write an O here is that all of our conversions are in powers of 10. Okay, so if I write a power of 10 here, for my base unit is going to be equal to 1 unit. Okay, now if I was going to write 1 unit as a power of 10, I would have to write 10 to the 0 power. If we think about our law for powers of 10, if we think about our law for our powers of 10, let's think about this for a second over here. Our exponent tells how many zeros behind the 1. Okay, so for our powers of 10, so for example, if I have 10 to the 2nd power, I'm going to have 2 zeros after my 1. 1, 2. If I have 10 to the 3rd power, I'm going to have 3 zeros behind my 1. Now, this is where some people get tricked, okay? If I have a 0, how many zeros am I going to have behind my 1? None, okay? So I'm just going to have a 1 there, okay? And now my decimal point goes there, okay? We always have an imaginary decimal point behind any whole number, okay? So now we know why our base unit has this O right here. It's because we're talking about it being 1 unit, because 10 to the 0 power is 1 unit. Okay, so now in order to talk about these are all going to be increasing. These are going to be getting bigger in my exponent. Okay, so if I talked about each one of these, for this D, that's deca, we'd have 10 to the 1st. The H, that's hecto, that is 10 to the 2nd. Kilo is 10 to the 3rd, okay? Now let's take a guess right here with this mega. If I've got these going up by 1, but then I've got these 2 slashes here, this one should go up by 2 more plus 1. So mega is actually going to be 10 to the 6th more than my base unit. Okay, so now I'm going to talk about this as the actual amount of units. This would be 10 units. This would be 100 units. This would be 1,000 units and 1,000,000 units. If I can write how many zeros are there. Okay. All right. So, and so on and so forth. So now for this one, this would be 10 to the 9th, and I don't really want to write how many zeros this is. And this would be 10 to the 12th. 10 to the 12th units. Okay. So now when we go this way, we're getting smaller. Okay. So our exponent above our 10 is going to be negative. Okay. So for our powers of 10, if it's a negative, the rule is negative exponent means smaller. Ooh, I did not write that. Smaller than 1. Okay. So for example, if we have 10 to the 0 power, that is not going to be smaller than 1. That's going to be 1, right? For 10 to the negative 1 power, that is going to be smaller than 1. That means we're going to have this, okay? Now, if we remember our scientific notation rules, this is similar to our scientific notation. So if I have 1 times 10 to the 0, I'm going to move my decimal point 0 times. So I'm just going to have 1. If I have 1 times 10 to the negative 1, I'm going to move this and make this smaller than $1 by 1 movement. Okay, so I'm going to move from here and make it smaller and move my decimal point there. And now when I write what it's equivalent to, I'm going to fill in my 0 and rewrite it. 0.1. Okay, so now we don't have to remember how many zeros go there by the exponent. We just remember how many times we have to move the decimal point because of our exponent. And we also need to remember which direction. Okay, so for this one, if I have 1 times 10 to the negative 2, then I'm going to have a decimal point there, and then I'm going to move to make this 1 smaller than $1, or smaller than 1. Go 1, 2. Smaller because it's negative, and 2 because the value of the exponent is 2. So now I fill in my zeros to make it from scientific notation into my normal form, and then remember this is where I put my decimal, so I've got to write what I have right there as my new form. Okay, so this is standard form. And this was scientific notation, okay? But this is this right here that I just wrote over. Now it doesn't really look like scientific notation anymore, but I'll just write it over here. And scientific notation should look like this. Okay. All right. So now, when we go back to our metric conversions, now we kind of see how this and scientific notation relate. It's because of this 10 to the power. Okay? These powers of 10. So now when we go smaller on our metric conversion chart, when we get smaller, we notice that our power of 10 is now going to have a negative exponent. So this is deci, this was deca, this is deci with an I. This is our nice familiar centimeter. That's about the length of your thumbnail. Okay, centi. Okay, centimeter is 10 to the negative 2. And these are all meters, okay, if you do meters. Now we could do centiliters, we could do centijoules, if you remember our little base units over here, okay? And so on. We've got milli, which is 10 to the negative 3. Micro, if we have our little skips, 1, 2, 3, it's 3 more or less. So we've got 10 to the negative 6, and then nano would be 10 to the negative 9, and pico would be, that's negative 9, negative 10, negative 11, negative 12, 10 to the negative 12. Okay? So that's the reason why we have this base unit, okay? So what I just want you to think about right here is why this base unit has the 0 right there, okay? Okay, and when we do metric conversions, we always have to go back to this chart. We always have to go back to the chart. And we always have to do these skips, okay? Now, we will move to work a problem now that we've reviewed the metric conversion chart. Okay, so let's work a problem, and there are 6 steps to any conversion problem, okay? So let's do our first problem, and let's do 300 grams and convert that to milligrams. So the first, well, let's just talk about our 6 steps. Okay, our 6 steps, 1 through 6, okay? Our 6 steps are going to represent how we're going to solve this problem. If you miss a step in this process, on your quiz, I will give you partial credit. However, if you miss any of the steps, like in math, your final answer is going to be off, okay? Now, the first step is always to set it up, okay? So I set up by just filling in what I have. Everything in front of the arrow is going to go in this square, and then what comes after the arrow is going to go in this second top square, okay? And that's step 1. Then step 2, I'm going to fill in my 1s, okay? So you're going to fill in your 1 here and your 1 there, okay? Then step 3 is going to fill in this bottom corner right here, okay? And after step 3, I'm going to explain exactly what you've already know in mathematics, if you've done any sort of mathematics before. So we always, with step 3, we do 1 times 10. First, we set that up, and then we also put our grams down here. Now, you're always going to cancel these in our 4th step before you multiply across, but we'll get to that in a minute. Okay, so during the 3rd step, we write all this. Then we have to find this last missing exponent, okay? And how we're going to find that exponent, how to find exponent, should be an E, exponent, we're going to go to the chart. Go to metric conversion chart, okay? This chart, okay, I'm going to write it out again because that's messy up there. Okay, so think, 2 slashes are important, goodness, my kids have dropped over, that's our base unit, so that's liters, meters, and grams without anything in front of them. Then we've got, so this was dec A, this is dec C, and then centi, milli, and then micro, which you can write this special little thing that's also micro, and then we've got nano and pico, okay? So now, during step 3, we're going to find where we're going from to what we're going to. So in order to see this, you can write a 1 here, and then what we're going to there, okay? You're always going to start at what you're going from first. That's why we put a 1 there. Then what we're going to, it's going to be milligrams, so let's just write grams. Grams is our base unit, right? And so it lines up right, very well right there, okay? And here is our milli, and so we know that that's where we're going to because we've got this M right here. The M in front signifies that it's milli. This is not meters, okay? This is not meter grams. This is milligrams, okay? If we had milli in front of a meter, that would be millimeters, okay? So if you had milli in front of meters, milli in front of meters, it'd be 2 M's, okay? The second one is always going to be the base unit. Second, okay? If it's by itself, it's always a base unit. So now, this is all during the third step. Once you get this, it'll be a lot faster, okay? So now we go from what we're going from to what we're going to. So now we count our skips. So we go from 1, 2, 3, skips. Okay, so because we're going away from our big letters, we're getting smaller. That means our exponent is going to be negative, okay? And it's going to be the value of 3. So we're going to have a negative 3 as our exponent down here. Negative 3, okay? Okay, so after our third step, let me tell you about what this looks like. This looks like kind of when you multiply two fractions together, okay? So if I have 45 divided by 2 times 2 over 9, okay? This is what our fraction looks like, okay? And we multiply these fractions together, okay? We could write it like this: 45 divided by 2 times 2 over 9, okay? These are the same things, okay? Just two different representations. So if I was writing this up here, I could write it in fraction form as 300 grams. Not like that. 300 grams divided by 1 times 1 milligram divided by 1 times 10 to the negative third grams. Okay. All right, now let's just solve the rest of the problem. You know how to multiply two fractions together, okay? And that's what we're doing in this fourth step. Fourth step is multiply across, but before we multiply across, remember how we cancel things out in our fractions? So 45 and 9, we can cancel something out of those. 45 is just like 9 times 5, and 9 is in there, so we're going to cancel those two out. And then we've also got 2 and 2, and so we cancel those out and we get 1s. Okay, so now we've got a really nice, easy thing that we're going to multiply across. Okay, so now we're going to multiply what's left over. We've got 5 times 1 is 5, and 1 times 1 is 1. Okay, and that's a really easy way. Now I don't have to multiply 45 times 2. I don't have to multiply 2 times 9. Okay, that's what we're doing when we're canceling out the grams. Okay, now I don't have to multiply grams times milligrams. Who knows what that is? No one does. So that's the reason why we cancel out our grams before we multiply across in step 4. Okay, now we've got 300 milligrams. When we multiply across, 300 times milligrams, or 1 milligram is 300 milligrams. And then 1 times 10 to the negative 3. And there's no grams, okay? Now in step 5, we're converting to scientific notation. Okay. So we're going to convert the top to scientific notation. So 300 in scientific notation is just like this. So 300, we've got a decimal point understood right there. We're going to see if it's bigger than $1 or smaller than $1. If it's bigger than $1, that means we're going to have a positive exponent. It's less than $1, we're going to have a negative exponent, okay? So now we're going to go 1, 2, right there. It's bigger than $1 originally, so now we're going to have a positive exponent. And we move 2 places, so we're going to have positive 2 in our exponent, okay, for this scientific notation. Okay, so we're going to have the new exponent there, so 3.0, and then times 10, and now we're going to add our exponent to the top, or put in our exponent, and that's going to be a positive 2. So now I put that back into our problem. I've got 3.0 times 10 to the positive 2 milligrams over, now we bring over our bottom, 1 times 10 to the negative third. Okay, and if you followed me there so far, congratulations. That's excellent. If you followed me to here, that's really good. If you didn't follow me between this step and this step, the only problem that you're having is this scientific notation, so don't worry too much about that. You can just practice some more of those problems. Now, the final step, the sixth step, we're going to basically cancel these two exponents out. And the way we do that is by subtracting exponents. Okay? So now we subtract the exponents. So the top exponent minus the bottom exponent. And this is important because it matters. Okay? If I subtracted the top, if I subtracted the bottom from the top, if I did this, it would all be backwards. And that's all because we know that exponents that are on the bottom are really the opposite sign if I just put them on the top. Okay? So our exponent rules are just that exponents that are above, let's say, if this is on the top of a fraction, if I flipped this to the bottom of the fraction, it would equal the opposite sign of that exponent. And that's just, you don't really have to know that, but I'm just explaining why it's important to subtract the bottom minus the top, okay? Because if we had this, let's say I've got 1 over 1 times 10 to the negative third. If I put this on the top, you would do the opposite sign of this to make it be in the top. So it'd be 1 times 10 to the positive third on the top, right? And that'd almost be like I was subtracting, or I was multiplying by a negative 1, right? So if you were subtracting from 0 or multiplying by a negative 1 to the negative 3, right? And just putting that on top, okay? That's just why. Okay, that's why we don't do this. Why we don't do that? Why we do top minus bottom. Okay. All right, so if we do this, we've got 2 in the top minus negative 3 on the bottom. And it is important that we do a minus and negative. Okay, so 2 minus negative 3 is positive, because we've got, well, 2, it's really 2 plus 3. So 2 plus 3 is 5, so it's positive 5. Okay, so now I've got 3.0, you've got to rewrite it, times 10, and now you've gotten rid of this because you accounted for it by subtracting. 3.0 times 10 to the positive 5 milligrams. And that is going to be our answer. Okay, so if you followed me all the way there, congratulations if you know how to do this. That should be everything you need to know about converting. And with more practice, we'll get faster, so don't worry about that. Congratulations.